But for now, let's just push on with the story. Suddenly, we are heading for space. Except for one little problem. The Soviets managed to get there first and launched Yuri Gagarin. Once again, one of those R-7 rockets in a very crude sort of big cast iron ball of a spacecraft, which in fact Gagarin had to eject from after his single orbit because they hadn't quite figured out a landing technique yet. So he came down by parachute, and the vehicle came down and splattered. The Soviets still come down that way, by the way. They've since actually figured out how to solidly land these bulletproof balls that they put up. They fire off rockets right at the last moments as the ball is coming down by parachute. Just before it hits ground, rockets go off kind of like an airbag and cushion the thing, so it's only about a 10 or 12 G, thump, and then you roll for a while through the farmland and eventually get rescued, hopefully. It's an interesting procedure. It's one of the reasons why the Russians still use really well-designed couches for their cosmonauts, built to order, because that last moment is kind of rough. The Americans did it a little bit differently. Von Braun had an opportunity to develop, once again, what was a V2. This is basically the basic V2 configuration, but with a space vehicle on top. The Mercury capsule, the Mercury launch escape system, and Alan Shepard was launched into orbit. Of course, not launched into orbit, just launched into space. This rocket was not powerful enough to achieve orbit. It could only do a ballistic lob. Shepard was in space for about 2 minutes, and again, only knew he was experiencing a couple minutes of zero G because of the stuff floating up in front of him. Von Braun was working on bigger projects at the time, though, because the Space Task Group had already committed America to head for the moon. And it was recognized that these little firecrackers were not really going to do that. Von Braun was designing the Saturn rocket. Over here you see the Mercury rocket that launched Alan Shepard and Gus Grissom. This is the slightly larger Atlas, which launched Glenn and Sharon and Carpenter and Gordon Cooper. Both of those rockets were based on missiles, intercontinental ballistic missiles, and they were pretty rough rides. The Saturn was the first rocket that was developed for peaceful purposes. It was never intended as a war machine. And you can certainly see the size distinction of the Saturn V moon rocket. The original plan was to make it even larger than that. You heard Von Braun talking about the space station that he wanted to put up and orbital maneuvers that would take place. Von Braun's plan always was to put a space station in orbit that would be used as a way station to the moon, Mars, and beyond. It was called Earth Orbit Rendezvous, and he pushed really, really hard for this to happen. When it looked like that was going to be too expensive and they weren't going to give him a space platform, quick aside, we did a film a few years back about the making of the movie 2001 by Kubrick and Clark. One of the points that we made in that film, and Clark completely supported this, was that it wasn't really a futuristic look forward as much as a futuristic look back, because the technology used in that film really was Von Braun's orbiting space wheel, used as a way station for lunar trips. If you're familiar with the film, and if you're not, why not? You'll see those aspects in the first act. Von Braun actually wanted to build a much larger rocket. He wanted to do something called direct descent when his space station got knocked out from under him. And he wanted to build something called a Nova, which would have 8 massive F1 engines down here at the bottom and would literally take a vehicle directly to the moon, more or less in one piece. It was going to be absolutely massive, much larger than a Saturn V. He was stopped from that by good old American engineering and know-how, and also the fact that the plant they gave him in Michoud, Louisiana, the old ammunitions plant they gave him to build his vehicle, only had a 35-foot ceiling, which restricted the size of the first stage of the rocket he could build to 33 feet diameter, which is why the Saturn V has 5 engines and a diameter of 33 feet. Literally any larger, and it would have butted up against the ceiling of the Michoud assembly plant. Saturn V was built to be trucked out to its launch tower via this massive crawler tractor, this vehicle that would carry it beautifully, smoothly along this 3-mile sand and gravel road at about 1 mile an hour. It was such a smooth ride that just died a couple of weeks ago too. Gunther Wendt, the pad leader, used to ride out to the gantry up on top of the stack, and he would put his coffee on the front rail and wouldn't spill a drop. It was that consistent. And Werner was always one for the back of the envelope calculation. This is the base of the Saturn V, the first stage coming together as the first of those big F1 engines are being assembled. You can see how big they are. The engine belt is large enough to engulf a Volkswagen. And somewhere in there, as they knew what they had to lift, those engines were capable of 1.5 million pounds of thrust apiece. And this vehicle was designed to be literally half the size of the Nova. Instead of having 8, it would have 4 F1s. And von Braun one day was looking at that as it was coming together, and he said, you know, fellas, I think maybe there's room to fit a 5th one right in the middle. And they did. The 5th one did not have gimbals for steering purposes, but he managed to get one in there, which gave them another 1.5 million pounds of thrust, and was capable of compensating for the reports they were getting from Grumman, who was building the LEM, which was going overweight, and the astronauts who were insisting on new things like lenses and cameras and, you know, other groovy stuff that they could do lunar exploration with, and the weight just kept going up and up. So 7.5 million pounds of thrust became the launch power of this rather remarkable vehicle. While that was under construction, and construction on the Saturn started as early as 1960, NASA was, of course, trying to sort out its own problems. They were trying to figure out how they could actually get astronauts to the moon, flying out of Cape Canaveral. Of course, the Mercury mission was over, the last of the single astronaut missions. And they had designed and were now working on what was really considered a bridge to the moon, Project Gemini. In essence, a scaled-up Mercury. It would carry 2 astronauts. It was actually a far nicer vehicle than Mercury ever was. It had computer capabilities. It had fuel cell technology, so it could do long-duration missions. The astronauts could control this thing fully. It wasn't just a little bit of attitude control. They actually could fly this vehicle. One of the reasons it was so terrific, in fact, it was their favorite vehicle. It was designed by Jim Chamberlain, who was a designer of the Avro Aero. A rather unfortunate piece of history up here that caused the Avro Aero to be scrapped. If you don't know that story, you will when you go and look this up, won't you? It's worth knowing about. It's one of Canada's more shameful technological moments. But it was an interesting boost for NASA because the weekend after Black Friday in February of 1959, when the Aero program was killed by our government of the day, the Space Cast Group showed up and rented a hotel room in Downsview and brought all the Aero engineers through and interviewed them and hired most of them for NASA, for Project Gemini and Project Apollo. Got them their green cards instantly, flew their families down south. Nothing like that had ever happened before. And Jim Chamberlain was the guy who ended up designing the Gemini spacecraft, which, as I say, really had to prove 4 things. It had to be capable of doing rendezvous and docking, because docking would be necessary for lunar orbit rendezvous, which is going to be used to get astronauts to and from the lunar surface. It had to be capable of demonstrating spacewalk, and it had to be capable of demonstrating long-duration flight. The longest mission that was flown was 2 weeks. 2 astronauts sitting side by side for 14 days in a space smaller than the front seat of a Volkswagen. Contemplate it, because they certainly didn't want to do it again. You'll notice something else a little bit odd about the Gemini spacecraft as well. If you look at the front, I mean, this is sort of a bad example because what you'll see is it doesn't have a launch escape tower. It wouldn't have had one in orbit even if it had originally had one. But the fact is Project Gemini did not. As Project Mercury had and Project Apollo would. Project Gemini did not because the original plan was to land it on land, like an airplane. The astronauts kind of asked for this, and Jim Chamberlain had worked out a method whereby they could do it. The idea was that the spacecraft was going to come down on a Regala wing that would pop out, and it would basically glide down to Earth, and wheels would pop out, and they would land like pilots as opposed to splash and bob in the ocean, which they found kind of undignified. They tested that like crazy, and I'm going to show you a clip of some of that testing in 1 minute. And it really didn't quite work out, but because they were designing it that way, they were going to use ejection seats rather than a launch escape system. The astronauts would actually